Hi everyone, and welcome to TACoS Computer Science Day 4. I am so excited for today because we finally get to play with our joystick bit. So for today's video, you're going to need your joystick bit, you'll need your microbit, you'll need your microbit cable, and you're going to need two AAA batteries, which you're going to install into the back of your joystick bit. Today is going to be an introduction to the joystick bit, so we're going to talk about what it is, and then we're going to talk about how to start coding with the joystick bit, and then we're going to do 3 different activities. The first one is going to be an addition to our reaction game from yesterday, where we'll use the joystick bit to add sound to our reaction game. And then we're going to do an activity called using the joystick and buttons, and that's just going to be practice using the joystick bit's inputs. And our final activity for today is LED Sprite, in which we're going to use the microbit in conjunction with the joystick bit to move an LED across a screen. The joystick bit is an expansion board for the microbit. It has a joystick, 4 buttons, a vibration motor, a buzzer/speaker, and an on-off switch on the top, which works when you've got your batteries in the back. These add-ons on the joystick bit give us way more capabilities than we had with just the microbit. The 4 buttons work just like the 2 buttons on our microbit. They give us 4 more inputs, which let us define more output events. The joystick can be used just like the joysticks you might have used on a game console controller. We'll program it just like that later on. The battery pack attached to the back of the joystick bit allows you to use the microbit away from your computer. After downloading your code to the microbit, you can disconnect it from your computer and let the battery pack power the microbit instead. The vibration motor can be used to give feedback in a game or give notification that something has happened. The buzzer works with the music tab in MakeCode. You can use it to add sounds to a game, give a warning, or anything else that requires sound. To get started using the joystick bit, we need to add the joystick bit tab in MakeCode. So go to MakeCode and then scroll all the way down to this Extensions button. Click on that, and then search for joystick. And you should see the joystick bit pop up. If it's not first, it'll be pretty close to the top. Just click on that, and you'll see it added a joystick bit option. Anytime we want to use the joystick bit, we need to use a special block from the joystick bit tab called Initialization Joystick Bit. We almost always want the initialization joystick bit block to be the first thing that happens in our program, so always drag it into the top of the onStart block. This block sets up the joystick bit and tells the microbit how to use all the features the joystick bit gives us. Now that we've had a little bit of an introduction on the joystick bit, we know a little bit about its inputs, we know a little bit about what it does, let's put that information to use. We're going to start with a simple activity. And what makes this activity simple is that we've already done most of the coding for it. What we're going to do is we're going to take our reaction game from yesterday and use the joystick bit to improve it. This activity is called Musical Reaction Game. We're going to use the joystick bit's speaker to improve our reaction game by adding sound. We're going to do this in 5 steps. First, we'll load our reaction game code from yesterday. In step 2, we'll add sounds to our button presses. Then for step 3, we'll test those sounds. In step 4, we'll add a game over sound. And step 5 will be a final test of our code. Step 1. First, we need to load our reaction game code. Just like we've done every single day this week, we're going to go to makecode.microbit.org. Then when that page loads, instead of clicking on New Project, we're going to look at the projects we've already made and click on Reaction Game. If you can't seem to find this project, don't worry, we've got you covered. Just head to our website and then go to Day 4. Then just scroll down to the first activity, Musical Reaction Game, and then you can get the code here. Once that page loads, click Edit Code up here, and you're all set. Once your code is loaded, remember that we have to add the joystick bit extension to MakeCode. So go to the Advanced tab, scroll all the way down, click on Extensions, search Joystick, and then click Joystick Bit. Remember that we also have to initialize our Joystick Bit, so go into the Joystick Bit tab, click Initialization Joystick Bit, and drag that into the very top of your OnStart block. Step 2. Add sounds to button presses. Now let's use the speaker on the Joystick Bit to add a little flair to our activity. As long as we've put the Initialization Joystick Bit block in OnStart, the speaker on the Joystick Bit will work with any of the blocks in the Music tab. Go into the Music tab and grab a Start Melody block and place it above the Show Icon blocks that are showing check marks in both the On Button A and On Button B blocks. Now use the drop-down menu on the block to change da-da-dum to ba-ding. Step 3. Test sounds. You can test these sounds by clicking on your virtual microbit, but why don't we go ahead and flash our microbit so that we can try it out on our Joystick Bit. Go ahead and flash your microbit just like normal. Once your Joystick Bit is done flashing, go ahead and unplug it from the computer, gently, and plug it into your Joystick Bit. That's gonna look just like this. Once that's in there, you can go ahead and turn your Joystick Bit on and run your code. Great. That seems to be working, so let's move on to the next step. Step 4. Add a game over sound. Let's add one more sound from when we press the wrong button as well. Drag a couple more Start Melody blocks above the Show Icon blocks that are displaying an X. Feel free to experiment with the sounds and choose whichever one you like to represent game over. I'm going to use this wah 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 in my example code. Step 5. Test your final code. Once you've re-downloaded your code, you can test it again in your Joystick Bit. And I don't know about you, but I'm really excited to hear what this wah 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 sound is like. So I'm just gonna do that. I love that. All right, well, now that we've seen a little bit about what the Joystick Bit can do and how it totally enhances our experience with the microbit, let's move on and talk about its joystick and its buttons in our next activity. Our second activity for today is called Using the Joystick and Buttons. In this activity, we'll dive further into what the Joystick Bit can do, we'll learn how to use Joystick Bit code blocks in MakeCode, and practice using its main feature, the joystick. This activity has 4 steps. Step 1 is going to be exploring the Joystick Bit blocks in MakeCode. In Step 2, we'll talk about how the joystick works and its values. In Step 3, we'll write code in MakeCode to display the joystick values on our Joystick Bit. And in Step 4, we'll test it all out. Step 1. Let's explore the Joystick Bit blocks in MakeCode. Go ahead and make a new project called Joystick Test. And when that loads, scroll down and add the Joystick Bit extension. Now let's open the Joystick Bit tab and look at our new options. We already know about the initialization Joystick Bit block. In fact, go ahead and drag that into your OnStart block. The next 2 blocks should look pretty familiar. Using the buttons on the Joystick Bit is exactly the same as using the A and B buttons on the microbit itself. The only difference is that the On button pressed blocks for the Joystick Bit are in the Joystick Bit tab instead of in the Input tab. So, the button C is pressed and the On button C is pressed blocks work just like the button A is pressed and the On button A is pressed blocks in the regular Input tab. The motor vibrate for 100 milliseconds block does exactly what it sounds like. It allows us to buzz the Joystick Bit. For example, you could plug this block into an On button A pressed block to get the microbit to buzz whenever we push the A button. The rocker value of X block is a special block just for the joystick. It allows us to get input from the joystick on the joystick bit. Step 2. Let's talk about the joystick and its joystick values. Getting values from the joystick works a little differently than most of the inputs we've used so far. If you want your program to do something when you push a button, you can use an on-button press block, and any code inside that block will run. Unfortunately, there are no on joystick up or on joystick left or any other direction blocks, so if we want to know where the joystick is, we have to ask it. If you look at the joystick bit, you'll see that to the right of the joystick, there's an X, and above it, there's a Y. If you've learned about grids and axes, you might have already guessed that these represent the X and Y axes that the joystick moves around. Remember that rocker value of X block in the joystick bit tab? This block will always report the value of where the joystick is on the X axis. If you change the X to a Y, it will report the value of where the joystick is on the Y axis instead. The range of values the joystick can have across the X and Y axes are 0 to 1024. Moving the joystick left and right moves it across the X axis. When the joystick is fully to the right, the rocker value of X will report 0. When the joystick is fully to the left, rocker value of X will report 1024. Moving the joystick up and down moves it across the Y axis. When the joystick is fully down, rocker value of Y will report 0, and when the joystick is fully up, rocker value of Y will report 1024. By now, you've probably noticed the 512 in the middle. When the joystick is in the middle, its value across both the X and Y axes is 512, which is halfway between 0 and 1024. Step 3. Let's display our joystick values on our joystick bit. Now that we have an idea of how we can tell where the joystick is, let's test our values and see if they match. In the Joystick Bit tab, grab an On Button C is Pressed block. Inside of it, put a Show Number block from the Basic tab. Instead of showing the number 0, let's grab a rocker value of X block from the Joystick Bit tab and display that. Now let's do the same thing for the rocker value of Y when we press the D button. We can use this code to check our rocker value of X when we push C and the rocker value of Y when we push D. Step 4. Let's download our code and test our joystick. Go ahead and download your program onto your microbit and let's test it out. Push your joystick all the way to the right and push C. Push it all the way to the left and push C. Push it all the way down and press D. All the way up and press D. Then try leaving it right in the middle and push C and D again. Did you get the numbers you were expecting? You might notice that the values aren't exactly 0, 512, or 1024. Mine were even a little bit off, but they should be pretty close. Small differences in the manufacturing process can cause the numbers to be slightly different. The numbers your joystick bit reports could be slightly different than what another joystick bit reports, so we have to keep this in mind when we write our programs. You'll see that in the next activity. Now that we've confirmed that the joystick is reporting values close to what we were expecting, let's write a program that lets us guide an LED sprite around the microbit screen. We'll do this in 5 steps. First, we'll set up the IfElsif chain. In step 2, we'll create a sprite. Step 3 will be finishing our IfElsif chain. In step 4, we'll add a delay. And finally, we'll download and test our code. Step 1. Set up the IfElsif chain. To start our program, we want the ability to do different things depending on where the joystick is. If the joystick is left, then move the sprite left. If the joystick is right, then move the sprite right. If the joystick is up, move the sprite up. And if the joystick is down, then move the sprite down. Let's go into MakeCode and create a new project. We'll call this one LED Sprite. don't forget to go down and add the Joystick Bit extension and place the initialization Joystick Bit block into our onStart block. Let's grab an if-else block from the Logic tab and put it into our forever block. Since we have 4 different cases, we need to add a couple more else-if statements to our block. To do this, just press the plus button at the bottom of the logic block. Click the minus sign next to the else portion to delete it. We only want if and else-if statements. Now, let's fill in each of the Boolean expressions our if and else-if statements are expecting. We'll do the first one together. If the joystick is left is our first Boolean expression, so let's translate that from English to blocks. Go ahead and grab a 0 is less than 0 block from the Logic tab and put it in your first if statement. Then replace the first 0 with a rocker value of x block from the Joystick Bit tab. Now, what value should we put on the right side of this Boolean expression? Looking back at our picture, the joystick should report 1024 when it's all the way to the left. So we could make our statement if rocker value of x equals 1024. But remember how earlier we saw that the joystick might report a number slightly different than 1024? To account for that difference, let's make our if statement if rocker value of x is greater than or equal to 900. 900 is a good compromise. It's high enough that we can be pretty sure the joystick is pointing left, but gives the joystick a little room for error if it's not reporting exactly 1024. Our next statement is if the joystick is right. This one is going to be very similar to the one we just did. Let's use 100 instead of 0 for the same reason we used 900 instead of 1024. Go ahead and fill in the next statement so that it reads if rocker value of x is less than 100. Try to fill in the last 2 if-else statements to take care of if joystick is up and if joystick is down on your own. Go ahead and pause here, try to do that, and when you're done, come back and check your work. Hopefully, you were able to finish your if-else-if chain without a problem, but let's just check and make sure everything matches. Inside your forever block, you should have this if-else-if chain. It should say if rocker value of x is greater than or equal to 900, else if rocker value of x is less than 100, else if rocker value of y, make sure you change that, is greater than or equal to 900, and else if rocker value of y is less than 100. Once you've got that all worked out, we can move on to the next step. Step 2. Creating the sprite. Now that we have the beginnings of our if-else-if chain set up, let's create our sprite. First, create a variable called Sprite. Then, under the initialization Joystick Bit block, set Sprite equal to create sprite at x2, y2 from the Game tab. Now we have a sprite stored in a variable, also called Sprite. We can use other blocks in the Game tab to interact with the sprite. Let's head back to our if-else chain and fill out each path our program can take. Step 3. Finishing the if-else-if chain. Our goal is to move the sprite in the direction that the joystick is facing. Luckily for us, there's a block in the Game tab called Sprite Change X by 1. We can change the X to Y in that block, and have it move in a different direction by changing the 1 to a -1. Let's figure out which values to use. The LEDs on the microbit are arranged in a grid, with the top left LED being at x0, y0. As we move left to right, the x value increases. As we move top to bottom, the y value increases. In MakeCode, you can hover over an LED on the virtual microbit to see what its x and y values are. Now that we know how the grid on the microbit works, we can figure out how to change the Sprite change x by 1 block to fit what we needed to do. To move the sprite left, change x by -1. To move the sprite right, change x by 1. To move the sprite up, change y by -1. To move the sprite down, change y by 1. Let's do the first one together. Go into the Game tab and drag a Sprite change x by 1 block into your first if statement. We know that our first if statement is checking if the joystick is pointing to the left, so we want to move the sprite to the left. All we need to do is change this 1 to a -1. These values can be tricky, especially the y values. Make sure to pay close attention as you fill in the if-else block with Sprite change x by 1 blocks. Do your best to fill in the other 3 conditions with modified versions of the Sprite change x by 1 block that we just completed. Go ahead and pause here, try that, and when you get back, we'll check your code. Welcome back! Before we download our code, let's check and make sure everything is right. So, your code, it should be in the forever block. It should say if rocker value of x is greater than or equal to 900, then Sprite change x by -1. So that should move the sprite left. Else if rocker value of x is less than 100, then Sprite change x by +1, and that will move your LED to the right. Else if rocker value of y is greater than or equal to 900, then Sprite change y by -1, and that's the tricky one because going up means you subtract from the y value. And the final one, else if rocker value of y is less than 100, then Sprite change y by +1, and that will move your LED down. Once you've finished, download the program to your microbit. You should now be able to move the sprite around your screen. If you're testing your code, you've probably noticed that your LED does move around, but it moves super fast and it's really hard to control. That's because the forever block runs as fast as the microbit can possibly go. But we do have a way to slow that down. Step 4, adding a delay. In order to slow down our forever block, we can add a delay in the loop. Grab a pause block from the Basic tab, and make sure that it's set at 100 milliseconds. Now your code should look like this. Step 5. Download and test out your program. When you're finished, go ahead and re-download your code, plug your microbit back into your joystick bit and turn it on. I think that you'll find that the LED is much easier to control now. We can move by 1 block, which we couldn't do before. But if you want to, you can keep playing with that pause value to speed up and slow down your LED. That's everything that we have for you today. Today we went over an introduction of the joystick bit and how to code for it, and then we did 3 activities. First, we did a musical reaction game, which was taking our reaction game from yesterday and making it so much better. And then we practiced using the joystick and buttons on our joystick bit. And then our final activity was this LED sprite that we just finished. Tomorrow, you'll use everything you've learned over the past 4 days to make your very own snake game.